Well, in part 1 of this video, we did an introduction and showed some of the payload inspection. We went in more detail in part 2 on the suspect content and entity alert. And now, no conversation is complete on the topic unless we talk about encryption. Because the fact of the matter is that more and more things are going over TLS or SSL. And how do you inspect that? Well, while in QNI, I've read that there are some capabilities of storing keys and doing decryption. I wouldn't use those boxes for that. I mean, those boxes are meant for inspecting the payload, and that's heavy enough. And there are dedicated appliances that do the decryption, and then they re-encrypt. They do kind of a mine in the middle, and provide that traffic to QNI for inspection already decrypted. So all that is fine. But I just want you to know about a technology that allows you to see things even when you cannot decrypt. Because sometimes the reality is that even when you put man in the middle type of thing, sometimes that encryption may break some things, and you may not get the certificate pinning. There are other things that will not allow you to do that. And then you need to let that encrypted traffic go through. But are you going to trust what is going on in there? You don't have to. JA3 is a technology that was created by some folks in Salesforce. And let me see if I can explain how this works in a simple way. Before the encryption, or when the encryption negotiation is going to start, the client sends an SSL hello that contains some information. I took some screenshots of some client hello protocols. And as we can see, for example, if it's a Google browser, it will do some things and it will have the order of the cipher. If it's another type of browser, will do it differently. If it's a specific application that uses HTTP, or will do it differently, differing. The point of the matter is that every client and also every server has a very unique combination of these parameters. It's very specific. Well, and also malware. When a malware communicates, it's going to have, and it's going to hide behind an SSL session, it's going to have all these things. Well, what if we take a hash, an MD5 hash of these and these and these, and when we know what these things are, then we put them in a table and say, this is a Google browser, this is a Firefox browser, this is malware, whatever, a TrickBot, and then this is actually very nice, because when QNI sees this traffic going, it also is going to do the MD5 hash of the client hello of every one of the things, and then it's going to look into that table and see, this hash with which technology correspond, and boom, and say, well, this is a Google browser. Well, that's fine, but you have ways of finding malware on that, and there are tables of JA3 hashes for client and for servers in GitHub and all the sources that you can actually access. And by the way, the corresponding one for the servers is JA3S, right? So that's how you differentiate one another. So let's see that in action in Curator. I ran some malicious packet. I replaced some packets here in my demo system, and I have this search which I'm going to explain in a second, and it did find hits on a table. Let's actually take a look at the SQL rather quickly, but you don't have to do it the SQL way, but I want you to see them both. The first part is just standard, the application, get not the number, but the application name, and that's what we see here. And then suspect content description, SSL TLS version, and then this is this part. I don't have it, expanded in here, right? But you can actually see what it says: non-standard port, standard port, and by the way, if you can even do these things from standard filters. But again, let me show you that later. Continue with the SQL command, and then the interesting thing is in here, right? We're gonna get that TLS JA3 hash, which QNI computes, and it's actually right here. It says as JA3 in this column. But then, what we are gonna be doing in here, notice that here is the JA3 S, by the way, on the server side, and then on the last column, what we have is look into this reference map, and we're gonna see that reference map in a second as well, and see the correspondence of that hash into what is it that it is. And we can see this, for example, this example where it detects some malware, test, FTP, banking, phishing, traffic site, etc. Right? And the rest is just, standard stuff, except for the N, which we are doing a filter in here, say where the SSL TLS session is not null, because I don't want to see a bunch of NAs in here, and when in the content of the possible user agent we find something that has the word MAL, as malware, if that text is anywhere in here, then we're going to put it in that search. So that's the power of AQL. It's a lot easier once you get a hang of it to get only the information that you want. Just for completeness, let me actually hover over here. You see that there is the word malware in there. I don't know if you saw it. Let me put it one more time so you can actually see it. Which says Brazil MLA span, and before it says malware test. So, and that's what you actually got, those hits. If we go to the reference map, actually go using the free reference data management app. Remember that the table was called JA3 user agent, I believe it was. Yes, here it is, right? And we can even pick in here, and we see all those hashes. And for example, this is Mozilla, this version, Mozilla running from a Windows machine, and and this has to be very specific because there are multiple variations. You see, all this section is just on Firefox browser variation. But these guys took the time to get a bunch of those hashes, of JA3 hashes, and then those you can have them populated via stick and taxi, multiple ways, and now you have your tables ready. Particularly important to detect malware in this fashion, even though you cannot do the decoding of the SSL. I think it is a clever thing that QNI also supports. One more thing before I conclude this first part, because on the next video we're going to be doing something cool. Two things. One is also in QNI there is the capability of using what is called JARA rules to look for patterns. And this is the way that IPSs work, and there are a bunch of snort rules and stuff on JARA for detecting patterns. For example, WannaCry is a good example in which you can see a string of hex characters. Well, that denotes the presence of the malware, and that's what those things are there. So you can look for all kinds of patterns, and then you put all your JARA rules into a file, and then you load that file in here, and now you have that suspect content. That it can find those strings. So, and one more thing is that in order to watch this information from QNI, there's actually a nice Pulse dashboard, and we can actually see it in here. It's actually very, very, very good. I'll put in the video description of this and all my files, there is a link to a public box under the Pulse dashboards in there. I'm going to put this one that you can also So this video is getting already way too long. In the next version, we're going to do a very cool exercise on using QNI on a use case that just more in prepare for detecting the Ryuk ransomware malware.